Question 15 asks, let f be a function with a second derivative given by f double prime of x equals x times x minus 3 squared times x minus 6. What are the x-coordinates of the points of the inflection of the graph of f? So the point of the second derivative test is to find the concavity of the function f, and more importantly, where the concavity changes. So in general, the concavity changes when the roots of f double prime, before and after it, the signs change. So first, to find that, we have to set this function equal to 0. So 0 equals x times x minus 3 squared times x minus 6. So for this function or equation to equal 0, x can be equal to 0, 3, or 6. According to what we have, these are supposed to be the inflection points, but we don't know that for sure. They're only inflection points if the sign before and after changes or is undefined at that point. So to find that, we have to do sign analysis. So what we do is we pick points, test points from in each interval, this interval, this interval, this interval, and this interval. And we plug it back in and we find out the overall sign of this equation. So from negative infinity to 0, I chose negative 1. So you would get a negative number times a positive number times a negative number, giving you a positive number overall. From 0 to 3, I chose 1, giving you a positive times a negative, giving you a negative overall. And for 3 to 6, I chose 4, so it's a positive times a negative, so it's negative. And I chose 7 for this interval, so positive times a positive, giving you a positive. So based on these results, we see that the sign changes at before and after at 0 and 6, but not at 3. So we know 3 is not a point of inflection, and only 0 and 6 are. So we can eliminate all the choices with 3 in it. So that'd be B, D, and E. And we know that the points of inflection are both 0 and 6, so the answer must be C, and not A.